All right, these are the notes for the review of trig packet. Is that what it's called, guys?
Yep.
Okay, thanks. Right triangle trig is on here. Okay. Basic sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse, tangent equals opposite over adjacent. Those all sound familiar? All right. These definitions of x, y, and r with the x, y, and r become very important when you do things like talk about the sine of a 270-degree angle. Because if you know that that ordered pair is 0, -1, and you know the definition of sine, and the radius is 1 here, if you know that the definition is y over r, then you get -1 over 1, which is -1, okay? If you don't know those x, y, r definitions, those kind of problems become very tricky. All right, and then we have down here the reciprocal functions, cotangent, cosecant, and secant. And I always remember tangent and cotangent go together. That's not a problem. But cosecant is the reciprocal of sine, and secant is the reciprocal of cosine. S goes with C, and C goes with S, okay? All right. Then we have this, which I'm very concerned that you don't remember at all. If you are a junior, this will, if you're good at these, it will get you a couple questions easy on the ACT. There's always questions that have special right triangles, okay? 45, 45, 90. If I were to prove to you why this works, you would just do Pythagorean theorem, and you'd get over here 2x squared equals the hypotenuse. You'd square root both sides, hypotenuse squared, sorry. You'd square root both sides, and you'd have the square root of 2 times x is equal to the hypotenuse. Does that make sense? That's why that one works, okay? The hypotenuse is always the square root of 2 times the leg. This one is a little more complicated, but not really. They took an equilateral triangle, which is 60, 60, 60. Everybody good? They split it down the middle. Okay, it now becomes 30, 60, 90. Are we good? Rather than call this whole side x, I said, well, let's call this little piece x, because then this one would be the same, yes? And how long would this be? If it's equal to the same as this whole thing, it would be 2x, right? So basically it's 2x all the way around this equilateral triangle. Everybody with me so far? Then they took and said we need to find this leg down the middle. If we look at one of these right triangles, it has a leg of x, a leg of L that we don't know, and a leg out here of 2x. Using your brilliant algebraic brains, what is 2x times 2x? 4x squared, right? 2x quantity squared is 4x squared. If I subtract an x squared, I now have that leg squared is equal to 3x squared. If I square root both sides, that leg is equal to x times the square root of 3. So this leg down the middle is x square roots of 3. That means we have a short leg down here across from a 30 degree. I always call this the short leg. Okay. The long leg is across from the 60. That's this piece right in here. And the hypotenuse is 2x. All right, so over on this picture, one more time. Across from the 30 is the short leg. Long leg is over here, and hypotenuse is 2x. Coming back to you a little bit. Okay. And one more thing. Degrees to radians, a very quick demonstration of why that works. If I had a perfect circle whose radius was r, that may, okay, from this angle it looked pretty good. Then I look from front and it doesn't look too good. But anyway, it's a circle with a radius of r. If we took this radius and we made it out of string and we started to wrap it around here, guys, do you remember this from last year? 3 of those radiuses would get us to here. 4 of those radiuses, 5 of those radiuses, 6 of those radiuses. Uh-oh. There's a little extra gap in here. It turns out that it's 6.28 of those radiuses to get all the way around. What is that equivalent to? 2 pi. Okay? So the circumference, or the distance all the way around the circle, is 2 pi radiuses. Okay, this is a radius. But the angle that it cuts off when we put a radius distance here is called a radian. Whoops, if I could spell. All right, so it's 2 pi radians to go all the way around, or 360 degrees. Because we like to reduce things, we get 1 pi radians, 180 degrees. Now, that is the only thing I have memorized in this entire world. Okay, maybe not, but that is the only thing I have memorized. I don't remember, do I multiply by 180 over pi or pi over 180? Because I just use my dimensional analysis brain from science class, and I think about canceling out radians or degrees, and I put it whichever way I need it. Okay, so we'll come to that in a few minutes. Any questions so far? All right, let's start at the top. When I do trig, I always stand at the little acute angle that we're given here, this 20-degree angle. So I'm going to put my little smiley face over here. I'm standing right there. If I'm standing here, where's the hypotenuse in this picture? I'm recording before you get too crazy over there, okay? Across from the 90 is the hypotenuse. Right next to that 20 degrees is called the adjacent side, because that's next to where we're standing. And all the way across the triangle from us over here is called the opposite side. All right, I'm trying to find the opposite, and I know the adjacent. Opposite and adjacent. So I go back to the definitions, and oh, look right here, opposite and adjacent. I can use tangent. Notice it says the tangent of theta equals opposite over adjacent. So I need to put the tangent of 20 degrees equals opposite x over adjacent 8. I love proportions, my favorite things, cross, multiply, and divide, so I always put this over 1 and make it a proportion. So I'm just doing 8 times the tangent of 20. What mode do you think our calculator had better be in? Degrees. Okay, we need to put our calculator in degrees. Then we type 8 times the tangent of 20. I got 2.9. Anybody else? Okay. It says round to the nearest tenth, and it is inches. So we found x. Did I lose anybody on that one? Everybody remembers their right triangle trig? All right, one more example of that. Where am I going to put my smiley face on number 3? At B, I want to be at the acute angle, okay? And the smiley face just helps me remember I'm standing here. So where's opposite, adjacent, and hypotenuse from this position? Okay, opposite is clear over here where there's nothing. Adjacent is a leg. Which one of these is adjacent, guys? The leg that's next to us, this one's adjacent. And the x is across from the 90, so it's the hypotenuse. Okay, I have adjacent and hypotenuse this time. One I'm trying to find, one I know. Go back here, adjacent and hypotenuse is cosine, right? So I have the cosine of 26 degrees equals adjacent over hypotenuse. Okay, I very carefully chose this example for the only 2 I want to do of these, because sometimes students get these wrong. We're not multiplying by 20.5, right? Got to cross multiply, so you end up with x cosine of 26 equals 20.5, and then you end up dividing. Most of us have gotten to the point where we never show that work, but that's really what we're doing, okay? 20.5 divided by the cosine of 26. 22.8? Yep, me too. And it is centimeters on this picture. Any questions on those? All right, I'm trying to write neat. I did this fourth period and it was a disaster after I finished every page, so. All right, number 4, we are trying to find an angle. We're still using right triangle trig, but do you remember when you're looking for an angle, which key you always have to push on your calculator? Yeah, you need to push the second button and then either sine, cosine, or tangent, depending which information you're given. Very good. All right, so if I'm standing at angle B on this one, what's the 16 called? Anybody? The hypotenuse, and the 11.8 would be opposite from the theta. The theta is what this is called, or you can just say I'm finding angle B, I don't care, but I'm going to write opposite and hypotenuse is which function? So I'm going to write the sine of theta, whoa, got a little carried away with my theta there, equals opposite over hypotenuse. Is that a 16, guys?
Yes.
Thank you. Then I'm going to type second sine of 11.8 over 16 to undo and find theta. $47.5, anybody?
Yeah.
Any questions on that? All right, so can you try this one on your own? Yeah. This one will be opposite and adjacent, so tangent, but I hope some of you didn't even bother to type that in. Did somebody notice right away what was going on? If you have a 6 and a 6 and a 90, and those are the legs, it's an isosceles right triangle, so it's got to be 45. Okay, but it does work if you type this in. Everybody good? Excellent. We are on to number 6. Now, the biggest problem with these is doing too much. Okay, students think that it's asking them to find the angle, so they type it in and get an angle. It's not what it's asking. It says find the value of the function. Well, the value of the sine is just a fraction. The value of the sine says if I'm at theta over here, sine is opposite over hypotenuse, so I get 6 square roots of 14 over 25, and I am done. That one doesn't even reduce. Do you get what it's asking for, guys? Okay. Number 7, for the first time, asks for what's called a reciprocal function. What is cosecant equal to? Does anybody know? It's the reciprocal of 1 over sine. So if sine is opposite over hypotenuse, then cosecant becomes hypotenuse over opposite. So if we are standing out here at theta, right out here, what's the hypotenuse? Be careful. What's the hypotenuse in that picture? 25. And the opposite, that's supposed to be an O there. Opposite of where we're standing is 7. That's the cosecant. Those are pretty easy, as long as you can look at a reference sheet about what secant, cosecant, all that good stuff means. Right, number 8, same thing, we just have to draw the triangle. It says we have a right triangle and angle C is the right angle. It says in the directions. Make sure you read that part carefully, okay? Now, do you remember how it went? They do this all the time in textbooks, but if you have an A, B, and a C, then across from those, side A is lowercase across from capital A, lowercase b and lowercase c. I really never figured out why they use c, because it doesn't a lower and a capital look the same pretty much, but okay. I guess if you're typing, it's all good, right? You can tell the difference. This is, they want the secant of A, so basically our theta, or our little smiley face or whatever, is going to be up here at capital A. Lowercase a is 16, and lowercase b is 12. Secant is the flip of what? 1 over cosine, okay? Cosine is adjacent over hypotenuse, so when we do the reciprocal, we get, not that. We get hypotenuse over adjacent. So from where we're standing up here at A, what is, uh-oh. What do we have to do, guys? Yeah, we need to find this by Pythagorean theorem. So we'd have 12 squared plus 16 squared equals c squared. Anybody recognize this? It is a 3, 4, 5. This is 3 times 4. This is 4 times 4. So this one is going to be 5 times 4, which is 20.
Yeah.
Did somebody type out 12 squared plus 16 squared and then square root, and it turns out 20? That's another thing that is a big time saver on the ACT, is if you know some special right triangle, or I mean some Pythagorean triples, okay? They like to do 3, 4, 5, 6, 8, 10, okay? But there's also a couple other ones. 5, 12, 13 is a Pythagorean triple.
That was on my ACT.
Yeah. And sometimes they double it. They use 10, 24, 26. Did I do that right? Okay. So those are a couple good ones to know. What else do we have going on? We didn't finish this. We need hypotenuse over adjacent. That's what we need. Hypotenuse is 20. And adjacent to us up here is the 12. Can we reduce that? By 4? Did I do that right, guys? 4 becomes a 5 over 3. So the answer to the question is that the secant of A is equal to 5/3. Okay, again, C is the right angle. So across from that side C is the hypotenuse is 8. Doesn't matter where we put A and B. But across from B is a side B of 7. If we want the cosecant of A, up here is our angle that we're looking for. Cosecant is what? Well, if secant was the flip of cosine, then cosecant is the flip of sine, so it's hypotenuse and opposite. Does that sound right? Sine is opposite over hypotenuse, so we're gonna flip it over. Okay. From here, we need the opposite though, don't we? I was just making sure. Sometimes you don't need to do Pythagorean theorem because it's already, the information is there, but this one we do. So we need to find this missing side. I can call it little a. What? Square root of 15? So we get 15, and a is the square root of 15. So we end up with hypotenuse is 8 over opposite of our angle here is the square root of 15. And already we got to do that crazy math trick and get 8 square roots of 15 over 15 is equal to the cosecant of A, which I can't spell. Ugh. How many tries does Hofbauer need? All right. Are we on the back already?
Yeah.
Okay, excellent. This is very easy if you just draw a triangle. Is everybody okay with this one? We draw a little triangle. We say from our angle, wherever it is, The tangent is 4/3, so where should I put those numbers?
4 is opposite,
Opposite and
3 is adjacent.
tangent is opposite over adjacent. If I want cosine, I need adjacent over hypotenuse, so I need the hypotenuse.
5.
Yep, that's a 3, 4, 5 triangle. 3 squared plus 4 squared is 25, so square root is 5. Adjacent over hypotenuse from this angle, which leg is adjacent? The 3, so we end up with 3/5 as the cosine. Again, guys, it's not asking you to find the angle, it just wants the value of the trig function. So you want 3/5. Please don't type these in your calculator, okay? You need to write 3/5, okay? You need an exact answer. All right. I'm going to draw a triangle, but do I need to draw a triangle? You guys all realize that right away? Cosine and secant just flip over, so the cosine should be the reciprocal of that, which is 1/2. If you drew the triangle, if we were doing secant over here, secant is hypotenuse over, and we could make it a fraction by putting it over 1. Okay. Secant is hypotenuse over adjacent. So we could have done Pythagorean theorem and gotten square root of 3, but we needed just the cosine, which is 1/2. All right. We're changing degrees to radians, and the one thing in the entire world that Hofbauer has memorized is that 180 degrees is equal to pi radians. So if I have degrees, I need the degrees to cancel, so I'm going to put those where? On the bottom. And I'm going to put pi radians on the top. All right. I want these in exact answers, please, not decimal approximations. So if I'm multiplying here, what can I do to simplify that? The degrees cancel, as does a 0 if we reduce, right? 14 and 18 reduces to 7 and 9, so 7 pi over 9 or 7/9 pi. We generally don't label radians, they just leave them. You can write radians if you want, but you don't need to. There's no true symbol. Sometimes we use a little capital R because we want to make sure students understand that it's radians, but number 13 is in what right now? Is this degrees or radians? Okay, it's radians. There is no little symbol there, but it is in radians. So what do I need to cancel so that the radians will cancel? The 180 or the pi on the bottom? Okay, pi radians down here is 180 degrees. Now the radians cancel. Lucky for us, so do the pi. And we have 180 divided by negative 36. It's negative 5 degrees. Be careful, we don't want to lose that. We don't want to lose the negative or the degrees. Okay. So can you try these last two? These are actually ones you should maybe have memorized on the unit circle. It just means it goes, that's a great question. We don't have negative degrees in geometry, but do you remember last year we did, it means it rotates the other direction. Negative 5 would be in the fourth quadrant or going that direction around, okay? Good question. 6 goes into 80, 30 times pi cancels, and 11 times 30 is 330 degrees. Did I get that one right, guys? Excellent. And negative 120, I need to multiply by a pi over 180. 12/18 reduces by 6. We good? You will have to memorize the unit circle again, but not until second semester. Any questions on those kind? Can we skip down and do the last two on this side real quick? Because this has to do with degrees and radians as well. They kind of all do, but do you remember, does anybody remember what coterminal means?
Coterminal is at what hangs on another 360
Yeah.
degrees.
It means it ends in the same spot. I heard Carolyn pretty much say that because she had me last year, and that's my... It ends in the same spot. So coterminal, terminal meaning ends, okay? It means if I decide to go to this spot, that's 90 degrees, right? But I could also decide to do 360 and then 90, and that would be a 450 degree angle, and that would end in the same spot. Do you see what I'm saying? I could also do a negative 270, and I would be coterminal, meaning I'm ending in that same spot. Yes, remember this? So what do we need to do to find another name that's coterminal? Well, what did I do? Added and subtracted 360. For this one, actually, if we subtract 360, we get 22, so there's already one positive answer. You could have added 360 and, well, I don't know, what does that come out?
742.
Okay, that's fine. You can write 742, but this is also a positive answer. It does say we need both a positive and a negative, so if we subtract another 360, we get what? 338, thank you. So there's multiple answers, okay? I found two. You have to have a negative and a positive, but there's an infinite number of possible solutions. All right, gets a little trickier with radians because nobody likes fractions, but it's all it is adding and subtracting what instead of 360? 2 pi. If we need 2 pi to be thirds, though, we have to multiply top and bottom by 3, so we're actually doing what? 6/3 pi? That's the same as 2 pi, everybody okay? All right, what's negative 11 plus 6? So there's another negative answer. If we added another 6 pi over 3 onto that, we'd get what? 1 pi over 3. You could add another 6 pi over 3 and get 7 pi over 3, etc., etc. Okay? You need one negative and one positive.
I like to convert them back into. I like- I
Learn
like to-
fractions. Learn fractions. Okay. Yeah, because students like degrees better, but that one you had to convert and then convert back, so it wasn't really very efficient. But this one, we don't have to convert back. We're going to use degrees to find this, so let's just convert this to degrees quick. Okay, pi will cancel. Somebody do negative 13 times 180 divided by 4 for me.
512.
How much?
Negative 512.
Okay. And we really want it in a positive number because we're better with positive numbers. So can we add a couple 360s to that until it becomes positive?
135.
Okay. Now, I need you to be able to find this secant of 135 always and forever the rest of your life. A 135 degree angle is around this way, right guys? We need the reference angle, which means the angle the rest of the way to the x-axis, right in there.
180 minus 135.
180 minus 135 is 45 degrees. Okay, without a unit circle, I want you to be able to do these by thinking about a 45, 45, 90 triangle. You didn't think I put those at the top for fun, did you? How's it go for 45, 45, 90? The two legs are the same, right? You can use one, yes? And the hypotenuse is square root of 1. Really? Square root of 1 is 1. Square root of 2. It's x, x, and x square roots of 2. You can use 1 in the square root of 2. Doesn't matter. Because the x's are going to cancel out when we do our ratio. Anyway, We're supposed to do secant. We're standing here always with the x-axis. Secant is hypotenuse over what? Adjacent. So hypotenuse over adjacent. You know what? I think I did this question wrong last hour. I did x square root of 2 over x. Why is that wrong? It should be negative. Somebody said it. We're in this quadrant. Going this direction is negative, right? So the x's do cancel. So we end up with a square root of 2 over negative 1 or negative square root of 2. At least I wasn't recording last period. That's supposed to say negative square root of 2. I didn't do a very good job there either. Okay. I forgot the negative last period. Cosecant. This is a much easier question because 300 this way leaves us what reference angle, guys? 60 degrees. And everything in this quadrant is positive, right? The only problem is you gotta remember the relationships between these. The short leg is x, the hypotenuse is 2x. Anybody remember the long leg? X square roots of 3. All right, cosecant is hypotenuse over, it's a flip of sine, and sine is so it's hypotenuse over opposite. From this angle here, hypotenuse is 2x, and opposite of us is x square roots of 3. Now, the x's cancel. We have 2 over the square root of 3, which, thanks to some evil mathematician, we have to make 2 square roots of 3 over 3. Yes?
I don't understand where you put in the x's. Like, why are you even dealing with this?
Because I'm not introduced the unit circle, so I'm not thinking of this as a 1. I just know that the relationship is always x square roots of 3, and 2x, or whatever letter you want to use, because it's a 30, 60, 90. Yeah, but they are always going to cancel out. So you could definitely do 1 square root of 3 and 2. When we get to the unit circle, we actually put a 1 here on the hypotenuse, and that's what makes this 1/2 and the square root of 3 over 2. Remember, the unit circle has lots of 1/2s and square root of 3's over 2 and square root of 2 over 2 and all kinds of fun. All right, real quick, let's finish the last couple. 270 is where? Negative 270. Negative 90, negative 180, negative 270. It's right on this line. There is no triangle involved, okay? The ordered pair here is across 0 and up something. I'm just going to use 1. Doesn't matter what you use. The definition of tangent. Anybody know the definition I'm looking for? Tangent is y over x. Okay? So if you put 1 over 0, what do we get? Okay, so the tangent of negative 270 is undefined. If it had been the cotangent, it would have been 0 over 1, which is 0. If it had been the cosine, it would have just been 0. It's x. Because the r here is just 1, the radius out here is 1.
So sine is 1, right?
Sine is 1, yep. All right, last one of these. Negative 7 pi over 6. Okay, if you hate radians, pi cancels. 6 goes in here 30 times, so negative 7 times 30 is negative 210. Did I do that right? Going all the way around this way, we wind up in quadrant 2. How far past 180 did we go? 30 degrees. So we have a 30, 60, 90. I'm going to redraw that because mine looks like a 45, 45, 90. And now it looks even worse. $30 here, 60 here, 90 here. Okay? Short leg is x, hypotenuse is 2x, this one is x square roots of 3. Because we're over in that quadrant though, which one is negative? Going left is negative, right? Okay, what's the sign? We don't need that anyway, because the sign is opposite over hypotenuse, which would be x over 2x, and what does x over 2x reduce to? 1/2. Kind of remember those a little bit? All right, these are easier. This says, it's still on the coordinate plane, but we get to draw the triangle just using the ordered pair. So if we go to the right, 2 square roots of 5 and up 4, we're out here somewhere. If we draw a triangle and we use the reference angle as the angle with the x-axis in here, then tangent is opposite over adjacent if you want to use that definition. So what would we have? Which reduces to 2 over the square root of 5, which then rationalizes to what? 2 square roots of 5 over 5? Could they get uglier numbers? Probably. What quadrant are we in here if we go left and up? So we go left 8. And then up square root of 17. Connect that back to the origin and use our angle with the x-axis. Cosecant is opposite over hypotenuse, yep. Hypotenuse over opposite when we flip it over, right? Okay. So we need the hypotenuse. So we need to do negative 8 squared plus the square root of 17 squared, which is 64 plus 17, which is 81. So when we square root, we get 9 for our hypotenuse. So hypotenuse over opposite is 9 over the square root of 17. 9 square roots of 17 over 17. Is everybody okay? Did I do that one right? Is that the last one?
Yeah.
Okay. We still have about 10 minutes. Is there something someone has a question on for the homework check, or something you look at that review sheet and you want me to go over? Which reminds me, I need copies of all of this for Sierra. Nothing? Nobody has a question? You're all brain dead?